Matrices from BCA first sem. In the previous video we saw about the types of matrices in a detailed way. If you didn't check means please go and check that one. Today in today's video we will see about the operation on matrices. First one is addition of a matrices here. Let A and B any two matrices of the same order. It should be a same order. Then their sum A plus B is a matrix whose elements are the sum of corresponding elements of A and B. If suppose you have, if A and B are the two matrices here, it should be a same order. If it is 3 by 3 and it should be also B is also a 3 by 3. If it is 2 by 3 matrix, then B should be a 2 by 3. Then only we can add both the matrix. Otherwise it's not possible. See here. Here we took here 3 by 3 matrix and B is also 3 by 3 matrix. Here A is a matrix. The elements are here A11. Why we denoted A11 means it's a first row first column. A12 it is a first row second column. A13 it is the place for the first row and third column. So we need to denote here A11, A12, A13. For the second row A21, A22, A23. In the third row A31, A32, A33. If you should adding both the matrices means you need to add the same corresponding elements. Like A11 you should add with the B11 only, corresponding elements only. A11 you don't supposed to add A11 to B12. You should add A11 to B11 only, A12 to B12. That meaning is you need to add the elements of both the matrices of the same order, same location, other same corresponding elements. Otherwise you can call it as corresponding element. So A11 you should add with only B11 only, A12 plus B12, A13 B13. What it indicates means it's a first one I, it's in the form of Aij. I indicates the which row, okay, and J indicates the which column, okay, which column. Now we'll do one example here, that is A equals to 2, 3, 4 and 1 minus 1, 2. It is a 3 by 2 matrix, and here also B is also 3 by 2 matrix. Let's see this one. A plus B. So how should we add? We should add corresponding elements. So 2 you should add with the minus 1. 2 plus of minus 1. Okay. If minus sign is there, that's the reason I took bracket here. 1 plus 4. 1 plus 4. Next second row, 3 plus 2. You can do with the row wise, otherwise column wise, which is your comfort you can do. Minus 1 plus 3. Next third row, first column, that is 4. Third row first column here 1. Here third row second column is 2. In the B matrix it's third row first column the second column is minus 1. Whenever it's minus came, you better take bracket. And the resulting matrix as also comes same order only, 3 by 2 order only. Now you should add this one. It's a 2 plus or minus is minus only. So 2 minus 1 is 1. 1 plus 4 is it's a 5. 3 plus 2 is 5. Minus 1 plus 3. If it both having the opposite sign means you need to subtract this one. It's a 2 and 3 is greater, so you should take plus sign. 4 plus 1 it's a 5 and 2 plus or minus it's a 1 minus 1. 2 minus 1 is 1. So our A plus B equals to, it's the our A plus B. Order is also 3 by 2. We will see another one question. As a C matrix is 1, 0, 20, 10. It's a 2 by 2 matrix. D is also 2 by 2 matrix. So C plus D will become here 1 minus 1, 0 plus 5, 20 plus 15, 10. Anyhow plus or minus it will come minus only, so I will write directly minus 5. It's a 2 by 2 matrix. It's also. So 1 minus 1 is 0. 0 plus 5 is, it's a 5. 20 plus 15 is the 35. 10 minus 5 is the 5. It's the resultant matrix is 2 by 2. Hope all of you understood this one, that addition of matrix we need to add the corresponding elements only. We will see more examples after the completion of concepts. Okay. Next is subtraction of a matrices. Otherwise you can call it as difference of matrices also. Here also the same thing. Let A and B two matrices of the same order, and their difference A minus B is defined as A plus or A plus of minus B, whose elements are difference of the corresponding elements of A and B. Now see here also the same process. A and B are the two matrices. It's compulsory it should be of the same order. It is a 2 by 2. We will see one example here by 2 by 2 matrix. So A minus B, 1. It's a minus, it's a subtraction, so you should take minus sign here. 1 minus 2, 4 minus 4, 5 minus 0, 6 minus 2. Okay. Same sign you should add and opposite sign we should subtract. You should remember this one concept. Okay. Here 1 is plus and 2 is the minus sign. So we need to subtract this one. Subtract means it comes 1, which is 2 is greater, that has the sign minus. So you should write here minus 1. 4 minus 4 is the 0. 5 minus 0 is 5. 6 minus 2 is the 4. So it's a 2 by 2 matrix. We will see another one question. A equals to 1 minus 3 4 5 0 7 Okay. I took A matrix here 3 by 3 and B is also 3 by 3 matrix. Now we will subtract it. A minus B. We should subtract the elements of A and B corresponding elements only. Okay. A you need to subtract in 4 only. 1 minus 4 minus 3. Second row 1 column 2 is minus 3 is here. It's a minus 7. So it is a subtraction. So you need to take, if whenever it's minus sign will come now, you take bracket. Otherwise you can you are doing A minus B na, otherwise directly you multiply and write. This is a minus sign, minus into minus it will become plus 7. Otherwise you take bracket. 4 minus 6, 5 minus 1, 0 minus 5, again it's a minus 3, 7 minus of minus 3. Okay. 2 minus 2, 4 minus 8, minus 3, minus 7. Now see here, I will write here only because it don't have space. Minus 3, it is minus into minus, it will become plus 7. Remember this one. It is also this. This is also 7, minus into minus is here plus 3. Whenever minus will come now, you should multiply and write, otherwise you take the bracket. Okay. Opposite sign we need to subtract here. 1 minus 4 means, 1 minus 4 is, it's a minus 3. Because 4 is greater, you should take greater sign only, it's a minus 3. Minus 3 plus 7, it's a plus 4. 4 minus 6, it's a minus 2. 5 minus 1, 4, 0 minus 5, it's a minus 5, 7 plus 3, it's a 10, 2 minus 2, 0, 4 minus 8, minus 4, minus 3 minus 7 is minus 10. So this is our A minus B. It is also 3 by 3 matrix. Okay, hope all of you understood this one. Next is scalar multiplication. So let A be any matrix and K is any scalar. Then product is Ka is scalar multiplication obtained by multiplying each element of A. We should multiply K with each element of A. It is called as a scalar multiplication. So how we write? 6A. 6A, 6 into A, otherwise 6A. You have to multiply 6 with each element of A, not only one, each element. So how to write? 2 into 6, 3 into 6, we are multiplying with each element of the matrix. 1 into 6, 2 into 6 and 3 into 6. 2 into 6 is 12, 18, 30, 6, 12 and it's a 18. Okay, it's a 2 by 3 matrix. So you have to multiply with the constant with all the elements of A. It's called as a scalar multiplication. We will see another one question in scalar multiplication. A equals to, I'll take 3, 4, 5, 7. Okay. K we will take here 5. So we should multiply K with all the elements of A. So 5 into K. Shall I write directly? 3 into 5, it's a 15. 4 into 5, it's a 20. 5 into 5 is 25. 7 5 is a 35. 1 into 5 is 5. 1 into 0 is 0. 3 5 is a 15. 4 5 is a 20. 5 2 is a 10. 5 5 is a 25. 7 5 is a 35. 9 5 is a 45. So it is a 3 by 4 matrix. So I wrote directly here, I multiplied 5 with each element of A. Okay. Next we will see the properties of addition of two matrices. What are the properties? Okay, in the set theory also we studied about the properties here, and here also the same. We will see commutative property, associative property, identity law, inverse law and transpose law and cancellation law. Okay, commutative property we know that one, that is the sum of any two matrices and sum of the same matrices but interchanging. First we will take B and after that B will be our first matrix and A will be now become the second matrix. Then sum of A plus B and B plus A, both the matrices will come same only. So here commutative law will holds good. And associative law, here we will take the three different matrices, that is A, B, C. First we will add any two and after that we will add the third matrix. Here also first two matrix we will add and after that we will add with the third matrix. We will get the same answers. So associative law also holds good here. Identity law means if you any matrix you have multiplied with the zero matrix. Zero matrix we studied in the types of matrices. Zero matrix means all the elements are equal to 0, otherwise equal to 0 means it's called as a zero matrix. If A is added with the zero matrix, you will get the A only, and zero matrix plus A, it's also you will get the A matrix only. Okay, next inverse law. A plus inverse of A. Inverse of A means you have to change the additive inverse of all the elements. So it will come, the answer will come 0 matrix only. If you did the reverse, the inverse of A plus A means it also comes the 0 matrix only. So inverse law also holds good. Transpose of matrix. So A plus B, after adding two matrices, if you did the transpose, otherwise after transposing you added means then also answer will come same. So A plus B transpose equals to A transpose plus B transpose matrix. Next, cancellation law. A and B are the different matrices equal to A plus C. A plus C. Here, if you cancel the A is common in both the cases. A, if you cancel the A, then it will come B plus C. B, the matrix B equals to matrix C with. It is called as a cancellation law. Next, transpose property, already saw this one. The transpose of A of transpose equals to A. Transpose of A of transpose is also equals to A only. Next is multiplication of matrices. The product of two matrices is defined only when the number of columns of the first matrix is equal to the number of rows of the second matrix. Okay, that meaning is A is a matrix of order m by p, then B is a matrix of order p by n. So that meaning is the first matrix column should be equal to second matrix row. Then only we can add the then only we can multiply both the matrices, otherwise it's not possible. What is the condition? The column of the first matrix is equals to the rows of the first matrix. This is the important. Okay, then only we can multiply. Then only it's possible to multiply. Then the product of AB in the order, after that AB order will come here m by n. So the first matrix or whatever the order is, whatever the rows is there now, how much rows the resultant AB matrix is also come the same, and columns it will comes from the second matrix. Okay. See here, A equals to A11, here the elements are A11, A12, A21, A22. Here B is the elements are B11, B12, B21, B22. First we need to check how many columns it has. It has the two columns, C1 and C2. How many rows it has? 2. So we can multiply both the matrices. Okay, how to multiply? It's very important. Now see here. For that I will give one easy method. So AB equals to, you write down, if it is 2 by 2 matrix, now first you check the matrix. It is 2 by 2 matrix. It is a 2 by 2 matrix means the resultant matrix is also, it will come 2 by 2 anyhow, because it will take the rows from the first matrix and columns from the first matrix. So you write it down, R1 C1, so row 1 C1, row 1 C2, the resultant matrix you write down, R1 C1, R1 C2, R2 C1, R2 C2. Now see here, R you should take from first matrix, and column you need to take from the second matrix. Okay, now see here, I will take first here, this is the place for R1 C1. R1 means you the R1 from the first matrix, C1 from the second matrix. Okay, we will do row wise from the matrix. You should solve the question row wise from the first matrix and column wise from the second matrix. You have to do like that. I mark the arrow mark also. Okay, now see here, A11 into B11, A11 B11 plus, you are changing to the next column, second column, here second row. So A12 B12 B21, this one, sorry, B21 A12 B21. Next, it is a place for the R1 and C2. Again R1, A11 B12 plus A12 B22. Okay. Next, this is the place for R2 C1. A row you should take from the first matrix. R2 is what? A21 into B11, A22 plus A22 with B21. Next again, it is the place for the R2 and C2. Rows you should take from the first matrix. A21 into B12 plus A22 into B22. Understood? I will show an example here so that it will clear. So I will take first 2 by 2 matrix only. After that we will take other questions. 2, 3, 1, 4. B is here. 5, 0, 10 and 6. Okay. No, it is also 2 by 2 matrix. It is also 2 by 2 matrix. In the addition and subtraction, we check what is the order of matrix, and we will check the order of, it should be a same order in the addition and subtraction. Here, what should we check? The columns of the first matrix and rows of the first matrix should be same. Then only we can simplify. It may order may same, may not same. It's okay. But if it is a pair, I will show others examples also. First we will see this one. Okay. The first matrix the column is 2 and second matrix rows are 2. So we can simplify this one. Okay. A into B. A into B. AB. So here, how should we write here? You should take rows from the first matrix and columns from the second matrix. 2 into 5. You have to keep like this. 2 into 5. 2 into 5. Next, you have to take plus sign in between. Next, you will move to the second column and you should go here. Second row. 3 into 10. 3 into 10. Observe carefully. Next, I am doing here same. It is a place for R1, C1. R1 I solved from the first matrix. C1 I took from the second matrix. Now I am doing here R1, C2. R1 I have to take again R1 only. It is a place for R1, and C2 I have to take C2 here. Column 2. 2 into 0 plus 3 into 6. This is the place for the R2, C1. R2, C1. 1 into 5 plus 4 into 10. R2, C2. R2 is from first matrix, C2 from the second matrix. 1 into 0 plus 4 into 6. Now we will simplify this one. 2 into 5 is, it's a 10. 3 into 10 is the 30. 2 into 0 is 0. 3 6 is 18. 5 plus 40. 0 plus, it's a 24. So 10 plus 3 is 40. 5 plus 40 is, it's a 45. It's a 18 and it's a 24. So the A into B is also come 2 by 2 matrix only. Rows from the first matrix, columns from the first matrix. It is 2 by 2. Okay. We will solve another one question. Okay, now we will see another one question. A matrix is 2, 3, 5, 1, 2, 3. It has 2 rows and 3 columns. And B matrix has 3 rows and 2 columns. We need to check here columns. It has the first matrix 3 columns, and the second matrix it has a 3 rows. So we can multiply this one. This is the first condition. We need to check that one. A into B. I will write here first R1, C1, R2, C2, so that you can understand easily. So what is the resultant matrix? First we will write down that one. The resultant matrix means the rows from the first matrix, it's a 2, and columns from the second matrix, it is a 2. So the answer will come here 2 by 2 matrix only. So this is the place for the R1, C1, it is a R1 C2. It is a R2 C1. It is a R2 C2. Okay. Now see here, I told our rows we have to take from the first matrix A. We need to take from the A. And column you need to take from the which matrix? Second matrix. That is from the B. You remember this one. Here also, rows we have to take from the first matrix and columns you have to take from the second matrix. Okay. If you write like this means it's easy to calculate. Now see here, R1. What is R1? It is a 2 into 1. First 2 into 1 plus next element is 3 into 0 plus next element is 5. Here 5. You should check like this, rows wise from the first matrix and column wise from the second matrix. So 5 into 5. Okay. Next, this is the place for the row 1 and C2. Row 1 you should take from the first matrix, again 2 second column. This is the C1 and C2. This is the R1 and it is a R2. Okay. Again it's a row 1 C2. 2 into 2 plus 3 into 3 plus 5 into 4. Next, this is a place for R2 C1. R2 is 1 2 3 and C1 is 1 0 3. So 1 into 1 plus 2 into 0 plus 3 into 5. Next, R2 C2. R2 1 2 3, C2 is 2 3 4. R2 you should take from the first matrix and column you should take from the second matrix. It's R2 is 1 2 3, C2 is 2 3 4. 1 into 2 plus 2 into 3 plus 3 into 4. Okay. We will calculate this one. 2 into 1 is 2. 0 plus 25. 1 0 plus 35. 4 9 plus 20. 2 plus 6 plus 12. Next, it's a 27. 36. It's a 29. 30 33. It's 18 19 20. So AB matrix will become here. This is our resultant matrix, that is A into B. Hope all of you understood this one. Next, note here A cube equals to A into A square. Okay, same in the numbers how we will do na, the same thing here in matrix also. A cube means A into A square. A square, if you are multiplying with A, you will get the A cube. How to get A square? A square means you have to multiply A into A, then you will get the A square. If we need A to the power of 4 means A into A cube, then you will get the A to the power of 4. In generally we will call it as A to the power of n means A into A to the power of n minus 1. So we will solve one simple question here. It is A. We need to find out A square means how to find out here? A into A. A into A. A is here 1 2 3 1. Again A is also another. You have to multiply with A into A. So you should write same. It's same matrix. A into A. The same rule we need to apply. Okay. How to do? I will write here only R1 C1, R1 C2, R2 C1, R2 C2. I will mention also here. It's a R1, it's a R2, C1, C2. You have to take row 1, row 2 from the first matrix, C1, C2 from the second matrix. Okay, hope all of you got it this one. Otherwise, you write it like this. You will never forget. Okay. Now see here. Row 1, it is a 1, 2. C1 is column 1 of matrix 2 is 1, 3. So 1 into 1 plus 2 into 3. Next, R1 C2. R1 C2. 1 2 2 1. 1 into 2 plus 2 into 1. Next, R1 R2 C1. R2 is 3 into 1 plus 1 into 3. Again, R2 is 3 1 and C2 is 2 1. 3 into 2 plus 1 into 1. 1 plus 6, 2 plus 2, 3 plus 3, 6 plus 1. So it's 7, 4, 3 plus 3 is 6 and 6 plus 1 is the 7. The resultant matrix also 2 by 2. It's a A square. How to find out A square means you have to multiply A into A. If you need A cube means again you should multiply A square with A. So the 7 4 6 7 you have to multiply with 1 2 3 1 means you will get the A cube. So similarly you have to do same. We will see in the example when we solve the examples that time we will see that one. Next is properties of the matrices. In the properties of the matrices in the addition we saw before. Now we will saw the properties of matrices in the multiplication. In the addition, A plus B equals to, it's satisfied. A plus B equals to B plus A. Commutative property holds good in the addition. But in the matrix, A into B is not equals to B into A. Remember this one. A into B is not equals to B into A. So commutative law does not satisfied in the matrix multiplication. Okay. Remember, but associative law it holds good. Why? Because we will do in the sequence only. First we will do BC, after that A. Here A, B and C. So associative law holds good. Next, distributive law, A, B plus C equals to A into B plus A into C. Next, reversal law, that is AB transpose equals to, it is at AB. After multiplying you should do the transpose, otherwise B transpose into A transpose. First you should take here first matrix as B and second matrix as A. Identity law, A into I, but A into I into A. You can do that one because it's I is the identity matrix. Okay, identity matrix means we saw already the diagonal element should be 1 1 and remaining all are 0. This is the 3 by 3 matrix. And 2 by 2 matrix means 1 0 0 1. It's called as the identity matrix. Identity matrix means it's a scalar matrix whose diagonal element should be equal to 1 and remaining all the elements should be equal to 0. Then it is called as the identity matrix. Only principal diagonal elements are 1 1 1 and remaining all are 0. It's called as the identity matrix. You should remember this one. Okay. A into I, you have to take any A here. I will take the same. 1 2 3 1. You are multiplying with the I, that is 1 0 0 1. And if you are doing identity matrix 1 2 3 1, then you will get the same answer, A only. You will get the same answer in both the cases. If you take first matrix as A and second matrix as I, otherwise first matrix as I and second matrix as A, anyhow in both the cases you will get the A only. The resultant answer you will get the A only. Okay. Hope all of you understood this one. Thank you.